In this video, we're going to look at a different type of loop known as an indefinite loop. But first, I want to talk about how when we're printing with multiple print statements, we can get the output to stay on the same line. By default, when you use a print statement, when you call the print function, it's going to put an invisible new line character at the end of whatever you have asked it to print. And that's what causes separate print statements to print on different lines. So for example, if we have this for loop where we're printing I times 5 7 times for different values of I, because that print statement is executing 7 different times, we're going to get 7 lines of output. We can get separate print statements to print on the same line if we add a special end argument. So for example here I'm saying end equals the string containing a single space, and so instead of printing a new line character after printing I times 5, it's going to print a space, and the total output of the loop will look like this, where the individual values are separated by spaces. If I say end equals the string containing a comma, I'll get this output. We mentioned in an earlier video that for loops are called definite loops because the number of repetitions is fixed in advance. It's always the length of whatever sequence is being operated on. Sometimes we need what's called an indefinite loop, where the number of repetitions is either not as obvious or it's actually impossible to determine before the loop begins. So one example of that is if we want to write a function called print multiples that takes 2 inputs, a number n and an upper bound called bound, and we want it to print all multiples of n that are less than bound. So for example, if we pass in 9 for n and 100 for bound, we should see this output. In theory, we could use a for loop for this problem, but it's hard to figure out ahead of time how many repetitions are needed. And so instead, here's an approach we can take, and I'm starting off with pseudocode, so this is not actual Python code, but we have our 2 inputs, n and bound. We're going to start by initializing a variable called mult to the value n that was passed in. And by the way, this mult is an accumulator variable. You'll see that as we go on here. And then we're going to repeatedly, as long as mult is less than bound, do 2 steps. We're going to print the current value of mult, followed by a space, and then we're going to update mult to be n more than its current value. And that's going to keep getting repeated. And if you think about it, that mult is assigned mult plus n. That's going to take me to the next multiple. And I'll keep doing that, printing and then going to the next multiple, provided that mult is less than bound. As soon as mult is no longer less than bound, we're going to stop looping and print a new line, which will cause us to go down to the next line. Here's the corresponding Python code for this function, and you can see that this notion of repeating a block of statements as long as some condition is true is implemented using a while statement. So we don't say repeat, we say while some condition, and then we have the block of statements that we want to repeat. And this function, by the way, you'll notice doesn't have a return statement, and so when we reach the end of the block that makes up the function, we're just going to return. Let's trace through this when n is 15 and bound is 70. So we start by initializing mult to be n, so 15. Then we come down to our while header, and we start by testing to see if that condition is true. And it is, because 15 is less than 70. And so we go ahead and execute the indented statements, which are the body of the loop. We're going to print the current value of mult, followed by a space, and then we're going to update mult to be its current value plus n. And so that brings us to the next multiple, which is 30. We check the condition again, it's still true, so we print 30 and we update mult. And we keep doing this, checking the condition, if it's true, executing the body, until the condition eventually becomes false, and that happens when mult is 75. At that point, we stop looping and we go to whatever comes after, and in this case it's printing an empty line or a new line, which brings us down to the next line, and then the function is done and it returns. In general, we have the keyword while followed by our loop test, followed by a colon, and then the body, which like any other block is indented. Here's a flowchart to show how while loops work. We start by evaluating the loop test, the thing that comes after the keyword while. If it's true, we execute the statements in the body, and we go back and do the loop test again. If it's still true, we execute the body again, and we keep doing this until finally the loop test is false, at which point we go and execute the statement that comes after the body. Now, it's really important to notice that there is usually some key variable, the loop variable, that is in the loop condition. In this case, it's the variable mult. And you want to make sure that you update that loop variable somewhere in the body of the loop, because otherwise, if you don't do that, if the condition is true the first time you test it, it's going to stay true forever, and you'll end up with what's called an infinite loop. For example, here's our print multiples function. I've put it in a Python file along with one statement that calls the function. And if I actually go ahead and run this, you'll see that I'll get the multiples of 9 up to 99 as expected. But if I comment out the line where we're updating the loop variable, what does that mean? It means mult is going to stay 9. It's never going to get bigger than 9. And therefore our loop condition is going to stay true, and we'll get an infinite loop. So if I save this and run it again, you can see we get an infinite loop. It just keeps printing 9 over and over again because the loop condition never becomes false. And that's why it's important to make sure that you're updating your loop variable somewhere in the body of the loop. If this ever happens, by the way, you can just go up to the shell menu and restart the shell.